Well, I'm Sean, and this is Eric,
I'm Eric.
and today we are showing off our Arduino driving remote controlled car prototype deal.
It's basically a combination of everything you've been able to find online in tutorials and online learning in the last 5 years. Online learning has blown up. Everything you can't learn in university, the things that have come out in the last patch from last weekend, particularly. And so you just have basically everything is now available as far as hardware is concerned to the public in small pieces through Amazon or what have you. And the idea is to just see if you can combine all the small pieces of all of these tutorials and to see if you can't create some kind of a monster, to see what is actually available as far as opportunity, technological advancement with things that they're giving away, the Internet of Things. How far does that go, and what can we do to have a piece of that? And so this is our Internet of Thing, and this is our thing, and it's connected to the Internet, and we're going to go through a few of its capabilities and the things that we've added to it, and we can expound on many different subjects if anybody's interested. So we'll go from there. Sean?
Yeah, we'll start with a high-level overview of the components we're using, the hardware on here. I've got this up on the whiteboard here. Just around there. Okay, so basically, at the center of the thing is an Arduino Mega 2560, and that's actually a clone you're running?
Yeah, I'll join. I guess I will join you in the camera field as well. Obviously, I guess in the introduction, I was saying that this is very cost prohibitive, and a lot of these technologies, as you research them, are sometimes ancient, sometimes brand new. For instance, Bluetooth technology was invented by by Texas Instruments at the end of World War II. And that is entirely the spy technology that they were talking about through the entire Cold War, and all of the Get Smart technology and all of that. That was Bluetooth they were talking about, and Get Smart, and how you could just wire sweep antennas and how you could just walk into a room and have it attached to you. In the 60s, they had Bluetooth, and that's what they were using back then. So this is actually, as they've opened up its availability to the public, you come to find out that these are ancient military technologies that have just now been released to the public. And so most all of this has been used in such a function one way or the other anyway. But that's where Bluetooth comes from. And so when you get into the code of what Bluetooth is capable of, it's pretty amazing. And so that using a motorized technology, say, and our idea of this is that it might live on a four-wheeler, right? That a four-wheeler could push snow around. Okay, that's kind of our end game ideal of where a lot of these debugs and ideas, the usefulness of it would come from. Is so the idea is we live in Montana, and there's a lot of snow in Montana, and dealing with that in a cost-efficient manner would be profitable to everybody. And so having a team of these pushing snow effectively, unloading a trailer, sweeping a parking lot, and being able to keep even city streets swept automatically would be pretty cool. So as we expound on that, Bluetooth is here, but we have all the radios communicating with each other. And so we'll move on to, I guess, the next big piece of this, which is the Wi-Fi radio. The Wi-Fi radio is attached to a secondary Arduino. Boards are just basically pinouts that run on a microcontroller system that has been programmed through an IDE that is usually proprietary, but Arduino's been around long enough that it's been fully hacked and exploited to Visual Studios, Eclipse, Cool Beans, whatever your IDE of choice is, the Arduino framework, and its particularly truncated set of C commands have been initialized in. And so you can edit the script now anywhere you want. You don't need to use the Arduino IDE. So they have utilized that in both of these boards. These are both knockoffs. This is a SaneSmart brand. They make the cheapest board out there. They basically take the Arduino Mega chip and then they put it on their board and use a clone printout with a little bit higher grade parts, and it costs considerably less because it doesn't have the particular made in Italy stamp on it, which is what makes these Arduinos valuable, I suppose. Arduino is pre-Raspberry Pi as well. I suppose this is important to point out, and that's why we're using Arduino. Obviously, all of this could be ported to Raspberry Pi at any point, but the GPIO pinout layouts of the Mega, and we'll get into those, are the easiest to get to. There's basically this and then the Russian BeagleBone are the easiest clones to get into as far as playing with stuff. Okay, so what we talked about at the beginning was all these are just toys. Once you wrap them all together, you're starting to edge on military technology, unfortunately. And so we're talking about these hardware attached pieces. There's the LCD screen, which is comes in a beginner kit. That's pretty easy to learn, and that is a great debug system. It allows us to drive the car without it getting away from us. The accelerometer is a flight control MPU 6050, and this is for flight controls. It has full three-way accelerometer and full three-way gyro, and this is used in the Pixhawk, and it's used in all the high-end quadcopters that one might go out and purchase in the $1,000 to $4,000 price range. They come with these accelerometers, and there's even cheaper accelerometers. This one, again, mind you, is $15. And I'll mention if anything gets to over $15 in initial price. But at this point, imagine everything is, you can get two of everything for $15 a piece. Okay, so that's what our accelerometer gyro is the MPU 6050, and that is one of the most exploited. Like I said, all the quadcopters in sales today use that same gyro, and so we've gotten into that, and we'll talk about the libraries when we get code up. Sonar, which we have mounted both front and rear, gets sold in 5 packs for $3. Okay, and those are what we're going to talk about later, which we have up here on the notes, is timers and interrupts. That's kind of what the limiting factor of a lot of this is, which you could imagine if you were the company that was making this hardware in the first place, you could easily eliminate by adding more timer and interrupt pins and more subsystems for that purpose. And that would allow, but the Arduino is basically only as smart as 5 sets of timers and 3 interrupts, and that's about all it can handle on its single-threaded brains. As we finish back around, we have the L298D 2-amp motor driver that's operating our tank drive, which is 2 motors per side, and it's operating a tank capability. We'll get it out here and drive it in a minute. That operates on 6-pin, but a lot of these can operate on an I2C buffer, which is a 2-wire communication with a particular header that defines each piece on the 2-line wire. And you can hook the Bluetooth, the accelerometer, the motor driver, and the sensor all on a daisy chain and use just 2 wires in. That's a little bit cost prohibitive and outside the hobbyist way of doing it, but all of this is capable of doing stuff like that.
Speaker attached.
As we move over here, this is, like I said, it was a second Arduino, but it's a clone Arduino with the ESP E12 Wi-Fi chip built into it, which was released in March 2015 and became widely pressed as a dev kit on the existing board that we have it in the state we have it in. That was released to the public in September 2015, and we got it on the first batch. The ESP8266 is this chip that sits on the dev kit itself, and that's the ESP-12. I actually don't have anything but the 8266 in that series. So as far as the chip is concerned, it is the most popular and versatile chip out there, and it's starting to take on a lot of the characteristics of what old school Bluetooth can do, which is auto connect as soon as you enter a room, and fun stuff like that. We'll talk about some of that in the code.
We are currently using it merely as a Wi-Fi client connected to an existing access point, but it can also run as a team access point.
Yeah, it's fully capable of running as an access point, or as a repeater, or as a sniffer, or as it has a mode for anything you can think of the Bluetooth can do, it can do with Wi-Fi. So that's pretty fun. And so that is, this entire clone is built with that ESP Wi-Fi chip built into it, and it has also allowed us to have a whole nother batch of pulse width management pins on this board, and that's another thing that's prohibitive. Even with the Mega, which is why we have the largest size Arduino they have, only comes with 10 pulse width management pins out of the 56 digital I/O pins that are available to you on that board. And so it's kind of a bear, and you would have to daisy chain a bunch of these to get PWM plus to another I2C buffer with pulse width management on there, and that would be a whole nother mess. But it's entirely possible as an upgrade to do. So we are just using this as a spare bank of 5 more PWM switches, and that's operating a speaker, which is a single line analog that Shawn just basically spams to make fun noises at this point. But it's more of a proof of concept on the idea that with these Arduinos and the way that all technology functions, it's just voltage measurements, and it's just electrons moving down a wire. And with a simple set of tools like this, you can easily interrupt almost anything of that kind. So we could interrupt Wi-Fi, we can interrupt Bluetooth, and although we have it functioning, it's not set up right now. We have full 2.4 gigahertz bandwidth home phone. We can double that to the 5.8 gigahertz video feeds that operate security cameras inside of buildings. And this thing could also function as a security droid as well, where it can be on the 5.8 gigahertz network with the security cameras, and it can feed back security as it's doing its patrol loop, which we'll talk about in its known avoidance program. And we get into the code and we get it turned on and running. So it does a couple of cool things. As far as potential, you can see that when you start stacking up all of these $5 child's toys, that you get into security protocols, that you get into clearly military purposes, is one of the few reasons why anybody would have these. I believe that's why RC car technology never took off beyond toys, selling to children, because of the things you can do with them at long ranges is nefarious. And so, I mean, I suppose if you're looking for a protection reason, that's what we're talking about for a lot of these things. But these things, given the protocols that we have now set up with it, could work as a swarm, and it could work through a PC, Bluetooth, 2.4 gigahertz, 5.8 gigahertz frequencies, and they all access the exact same buffers. So that's kind of what's on there and kind of where those are pointed. And I guess we've talked about timers and it being single-threaded as the single most technologically prohibitive point of all of this, is that these things are consumer grade, and they're consumer grade clearly for a reason. And you could, using these consumer parts, especially ESP12, this Bluetooth technology, combine them on different types of PCB layouts to get access those massive amounts of timers, availabilities, speed, crystal speed, that kind of stuff for communications. And you could really build it out any way you wanted with just a few simple adjustments to the whole system. So, do you have anything to add?
Yeah, so that's basically the hardware we're using in place here. There's a couple pieces to the software side as kind of a, for the user perspective. Right now we have a Bluetooth mobile administration app that one of its purposes is to allow us to connect via Bluetooth and set up the wireless network on startup so that you can connect to an unknown access point, which we haven't programmed in. So that can connect to any access point. Obviously, your Wi-Fi isn't up, so you can't use the PC communication here. We're using Bluetooth to go ahead and set that up. That was a pretty simple application developing in MIT App Inventor, which is a web-based design tool to make Android apps put together pretty quickly. They've got a Bluetooth communication stack already in there ready to go. And then on the bigger side, we are using the Unity3D game engine to give us real-time telemetry data back from the boards, including the accelerometers and sonar pings, that sort of information. In a 3D environment with a mock-up car on there. It's maybe just a cube right now.
Right, but we'll talk about how silly our graphics are in our simulation. But the idea is pretty exciting in the first place, that we're getting through video game technology, we're getting really fast baseline stream data information from this NodeMCU here, this ESP12, into Unity3D, which is a video game engine and has built into it ways to transfer small amounts of information. And so we have a UDP pipe that basically sets the information and runs as a faux serial port with line registers in there to simulate serial port communication. And that's what we've used it for, and it's actually pretty crazy the amount of access that we have to the whole board when we've created that faux serial port communication from Unity. And so that's allowed us to pull in way faster than real time. Unity sits and waits for the car to pass it the information because we can keep the PC faster. It allows a video game developer to create avoidance protocols, anything that a video game artificial intelligence used to be able to do, this thing can now be able to go back through history and pull out all intelligences, the map following protocols, bad guys chasing good guys on the screen, swarm moving technology, how tanks move on a battlefield, how swarms of ducks move. I mean, any way in which artificial intelligence has already been written to work in video games, we'll be able to port that out to use this in real life. And that's, I believe, going to open up the door for us to get really crazy about using this in 3D environments. And that's where the flight control sensors come in. And so we've got all the different flight control sensors. We've got 3 directions of acceleration, 3 directions of gyro. And this is hopefully going to allow us to compensate motors on a three-dimensional, on the three-dimensional video game and in real life, in real time, so that if it's away from you, you should be able to fly it at mega long distances. And even crazier ideas is if it had, there's projects that exist on the internet where there's free Wi-Fi connections through downtown areas, through metropolitan areas. Technically, this thing could find a free Wi-Fi connection, connect back to Unity anywhere, then coordinate its motion with the motion of its swarm itself, where it is in its awareness, re-update its program, and continue to move. And so you might be able to expect things like this to be autonomously flying near free internet connections, because they will have eyes and ears from anywhere to anywhere through cafe internets. And I feel like that's clearly a potential issue in the future about security, but this is going to exploit stuff like that very soon, and that's kind of our working project. And so what it is capable of doing right now is it's got a sensor input avoidance protocol, which is pretty standard, but we've worked on it ourselves. Shawn has written that from scratch, which is pretty cool, and it's nothing really. It's going to actually run this thing in real life and not know anything about what it's doing. So none of the information is going to be stored on the car. None of the thinking is going to be done on the car. It's going to pour down all of its sensor readings. It's going to receive motor command, and then it's all going to be processed through Unity, and that's going on the PC. And easily you can understand that the idea of this right away is that you could do it from anywhere. You could operate this computer with simple programming and have this thing and the two be very far away from each other. And so, and then this thing autonomously, and none of its frames wherever it's operating from can be taken from, right? It's not producing any analytics on its own. So all of it, the analyzing of the data is being done far away at a home base protocol. And if this is ever captured or destroyed, in real time, nothing is being lost. Everything is always being transferred out of it. So it's kind of cool. So if you want to talk more about it, we could run it.
Shall we plug it in?
Yeah, we could plug it in and do some code, or we could just not plug it in and push the batteries in. I think we can push these tables together. Let's do that. Do you want to just run it on one table?
Let's push it.
And play goalie? So I'll play goalie, I guess, with the sensors for now because we don't have any confined obstacle avoidance. But I guess what's really been doing a lot of this is getting into flight stabilization controls. How you zero numbers that are coming into you in real time, how to create sine waves out of straight numbers, and how to use that in interpolated fields so that you can access the data from many different points. My point is that we've got a lot of different data coming in. We don't have to use it all to make all the decisions. Right now, we're only going to use the front and back gyros. Obviously, flight control doesn't do a lot. So, but it does have functioning flight controls. When we get to pushing it up here on the screen, the computer probably overheated, but you'll be able to see that. Shawn, you want to operate it on Bluetooth?
Yeah, I was going to see if we had HDMI out on Android.
I don't.
So I'm going to load up the Bluetooth app here. Basically, configuring a drive screen, and you start by selecting already paired to the device. It's connected to it now. We have just a simple menu system here. I can go to the drive screen and access drive control buttons. Okay, so moving forward. Right turn, left turn.
Oh! Pull it back so you can get it on the camera.
And what we see on the LCD screen here is our first line is giving us just some information on what the forward is it's receiving a go command. Forward is 200 here. Stop is 00. And then our bottom line is just a debug line coming from any of our communication. Right now we're just showing the IP address.
That's useful because obviously the Wi-Fi doesn't have the complete auto find, auto Bluetooth connect functionality that's obviously built into IP address technology. It's made so it can't do that. But that's why we have all the Wi-Fi protocols turned off immediately when the car starts up, and then has to be accessed through Bluetooth. And so it has to have known Wi-Fi communication to the Wi-Fi router and be logged into it to utilize it for any information purposes. And so will the laptop. And so they will have to know where each other are in the network currently.
So we start our communication from the Arduino, and it reaches out to Unity. So I'm going to punch in the IP address of Eric's laptop here. 1293. Once Unity receives that first packet, it's going to know the return address back to the Arduino. So we only enter one address here.
And that would also be known through the internet. The Unity protocols, like I was talking about, is that there will be a third-party game server on the internet that it will communicate with, so that it only has to be on a free Wi-Fi connection, and then it'll scream to the free game server, and then this will always know where the free game servers are. And so that will cut out at least half of where it needs to know where to go. But for now, we're using it through a direct access point where the two communicate directly to each other through a local IP. That will be defeated. It's just another enemy in the fight of working on this software. But yeah, we're getting pretty close on all of that as well.
So I'm now going to enable the sensor blast, which will start flashing this blue LED there. And what a UDP is a connectionless protocol. So even though he doesn't need to have Unity running yet, this thing is now transmitting as fast as it can over the wireless to that IP address, and just waiting for him to receive it. And we could connect back to this really from any machine to the UDP port that it's listening on and issue it drive commands. Or even reconfigure the wireless network can be done over the wireless too.
Right.
So you disconnect this off.
Appreciate you buying me the time I need to get this fired up.
So
Almost there. Right, I'm connected. Did we crash it?
okay, so you're receiving data.
So I'm receiving data. I don't know how well you guys see this. Easier to see part of the screen. I'll just wait from there. You go. So you can see these numbers over here flickering. This is the input data, and you can get a feel for how fast the data is by the error rate of some of these gyros. So how fast this guy's flickering is about the maximum speed of the car. And like I said, we're receiving the data and processing it far faster than it can send it and come up with data. And so that's allowing Unity to have thoughts in a multi-streamed ideal that neither of the Arduinos could ever hope to achieve. And so both of the Arduinos operate on a single-threaded, multi-limited timers and interrupts environment, but with software in Windows and in Unity, we can invent an unlimited amount of interrupts, an unlimited amount of timers, so that we can utilize an unlimited amount of functionality, which is only limited basically by the command protocol or the command computer
Again, once we update all of that to a game server, those, especially made for video games, can scale rapidly. So you could scale from one server to a dozen servers to 150 servers in a relatively short period of time, like a week. And so that's the way video games scale now, and that's the way Clash of Clans and most of these paid video games pay for their network and server space, is that operators expand and contract server space as necessary for each individual games, and games don't necessarily own their own server space anymore. They lease it. It's another part of their bill. And so we're hoping to take advantage of that, is our point, and that those game servers are just sitting out there. They're for lease. Anybody can use them. They don't have to know who you are, and that helps maintain the security of the unit if it was out in public, which is kind of cool. Right now, again, we're receiving data from it, and this is pretty cool.
Demonstrate the ping.
Okay,
so right now, your front ping right now
is, oh, it's floored.
It's kind of not responding, is it?
No, we did crash it though in warm up, so I'd apologize for that.
No goalkeeper.
Yeah, nobody was playing goalie against that lamp over there. We thought the lamp had it.
Weird ping, okay.
There it goes.
I think we're just delayed on our data.
All right, so here's what we're gonna do. I guess just to talk about Unity, I don't know what kind of experience or kind of questions you guys have about this or any interest, but Unity is a video game engine that games popular titles like Skyrim is built on, and it's a of the Unreal Tournament engine that was developed in the late 90s, and that was bought and paid for by a single user and then open to open source. And so today, Unreal Engine is used by many different games, many different people. This is just another knockoff of that, but it's the most popular one on the internet. And so we're using it as a free game builder, which is pretty cool because that's how we're, again, hoping to utilize the interface and the brains of this whole operation. The idea is that as a toy, if we repackage this as a toy, you could operate it off your screen on a free Xbox app. So you could get to the Xbox store, you could download this free game on the Xbox Live Store, and then you can start driving that car, and you get all the data up on the screen. Everything that we see here, you could operate this through an Xbox, through PlayStation 4, iPad, Android, Steam box, anything you can fucking imagine. So it's the entirely endless, the possibilities, and it's quite exciting. And that's why we get a little carried away in the discussing what the possibilities of this are, because it's quite extreme and very cool. As I pull this up, you can kind of see that we have this little robot model here on the car, and we have this streaming. Unity operates in two modes. It has a Unity editor and a Unity builder. Unity builder is the one in which your game will play. Unity editor is the one in which you build games. And so this is the Unity editor, and we have the data in real time outside of game mode. And that's just kind of really cool about the original functionality of Unity itself as a program. We are utilizing it as a program instead of the game engine. And so that's why we're not publishing the game. So it's pretty cool. So that's what this is. So now we're going to enter into game mode. And you see that that shuts off Unity's access to this. And we're going to restart it. And now this is what Unity is passing into our game. And so now as we begin to deal with that in the game, we can begin parsing the network. And when Shawn's ready to play goalie, we can use our first Avoidance Protocol, which Shawn can walk you through a little bit about what that's going to do.
The first brain that we did.
The first brain.
It's a pretty simple avoidance protocol that essentially is only watching the two sonar sensors, and when it gets its initial command is to drive forward. When it gets too near an obstacle, it will stop, turn a random direction for up to, I think, 2 seconds, but until a view opens up in front of it, and then it will drive forward again. If it turns for the whole 2 seconds, then it will stop, look at the rear sensor, try to back up for a small time, and then start over again.
And the way, and just as a point to what that's able to do, using just 2 sensors that I mentioned earlier in the talk were 5 for $3. You can recover enough data from the machine to make a functional toy. And so between that and the smaller NodeMCU, without the need of the Mega, and this software would be a saleable toy that could connect to Xbox, PlayStation, Android, iPhone, and would entirely serve a purpose, particularly with a number of these avoidance protocols in it that would be switchable modes. And then you could, as a player, sit here and physically play with the avoidance protocols on your own on the screen, because we have these as sliders, and so we can adjust the too close and too near proceed. And if you're wondering why the thing looks banged up and why we can make it more banged up, is because we can actually play with the avoidance protocol minimums and maximums and how it's functioning in real time while it's out there avoiding things. And so you could clearly set one of these to 0 and just let it start crashing into stuff, and it's an amazingly good time toy. And if it were built in a crash-worthy case, then it would entirely be a really good toy, especially if the thing lit up when it crashed into a wall. And so that's part of the build ideas of kind of where this is all going in our heads. Why we're doing all of this is that I personally have little kids. Making toys is kind of my whole life. I dig it. You know what I mean? So that's our idea. Is that it's already a toy, and that's just one of many different toy ideas that we've already kind of prototyped into this. It's playable. Shawn, you ready to play goalie?
Yeah, I'm not sure this is going to work.
I'm not sure it's going to work. I don't think it's going to work at all. I think it's going to drive right off
We've
the
done a lot
on
of
the table,
changes in
man.
the communication protocol the last few weeks.
But that's why it's going to be fun. Let's see what happens. Nothing. See? Isn't that beautiful? So let's start. Oh, man. So somewhere deep in my code here, through the porting of data to this computer, it has corrupted that single line back. Man, I almost had it too, Shawn. Unity runs on a single thread as well. Unity is expecting to update to a multi-thread computer PC style processing system, the way it processes its brains in the background. And that's going to allow it to use i7's faster computers that have hyper-threading of up to 16 cores. Oh, yeah. And so I'm really looking forward to buying one someday. And for now, my personal equipment is overheating. But as far as the car is concerned, that's what it's capable of. And that does entirely work. I apologize that it's not happening right this second. We were having a little fight with it this morning. But you could imagine that its avoidance protocol would be amplified by the gyro's ability to know where it is, know where it's going. And so as the gyro and the accelerometer track the motion data of the machine as it will allow it to not have to take in so much input on where it's going, because it won't travel backwards over where it's been. Shawn, you have anything to add? I guess what's taken the most effort in all of this is the communications protocols of actually making every device integrated and available to be turned on and off through an on and off system. And we've used those on and off and on systems through a Bluetooth app that we use through the phone, and Unity is also that, but that is where most of the effort has been. The car itself, again, isn't much more than a toy, but it's a collection of toys that can be turned into pretty bad nilly if it were upgraded.
I just quit talking.
Mm-hmm. You don't have a pull down on your speaker here. I'm wondering if you're blowing out that analog port.
It's actually a digital port.
Yeah.
PWM port. So yeah, if I see you're hot to the port, to the power, you don't have a pull down on that. Yeah.
Let's see. So the Arduino has quit responding.
Yeah.
You need to reboot it. Okay, you wait. Reset.
It's the MCU. It's hung up on.
What's the reset on that?
Try full power. Power up.
I've designed the power system for this little car myself, and so it's very non-sophisticated. It's basically just a bank of capacitors that run out proper voltage to the right 3 different zones on the car itself.
Here's the Bluetooth.
And I'm utilizing the new technology of
And this is through accelerometer?
And these bad Charlies
Doesn't
right
always
here
connect first
have
try.
increased consumer use
Welcome
of
to
batteries dramatically. And so it has allowed a consumer high voltage, high amperage, high discharge battery to go on the market in a handheld size in AA form
Switch
factor.
to the node.
And
view.
so
So now it's passing
we're actually
through to
using
get
2
the menu
3.7
off the
volt
other Arduino,
AA
Okay.
form factor batteries
which is where
that have
Stanford
5,000
networks.
milliamp hours of battery life, which is a lot. And they're in that same form factor
Hard to put it in
upgradable
right now.
to, I think, 10,000 milliamp hours of battery life before you have to get into the next double long size form factor.
Disconnect.
But them working as just super AA batteries is super efficient, and it's a lot of power, and it's more power than any RC car ever had.
Is this soldered on? Or is this soldered on?
And it just started making noise.
Yeah, now we're over. So I need to increase my net connection wait beyond 10 seconds. Sometimes it's taking just about 10 seconds to get the timeout.
What are these sensors here? A proximity sensor? What are they?
Those are ultrasonic,
Oh, sweet.
and they basically break down to the data registers on the library for it, and it's entirely modifiable. to get warnings if it goes out of sensor range and these kinds of things. Can trip all sorts of sensors, but they're set up identically to the $100 ones, which is really cool. They use the same library, and so they operate in the same identical fashion, using interrupts and the timer libraries as the $100 sensor for those. And those have a 6.5 meter range. We're dealing with 250 millimeters right now. Centimeters, millimeters, 250 millimeters.
Do you dedicate? There's a Arduino of some sort here with this Wi-Fi chip. Is that dedicated for communications?
That Arduino has that Wi-Fi chip built into it.
There's our diagram on the board. That's the NodeMCU,
Okay.
the Wi-Fi. So most of our sensors and everything are hooked to the Mega. The Bluetooth is on the Mega. We log in to the Bluetooth in order to assign the wireless network that the node will use. So those talk to each other. And we have a basic protocol on both of those so that they can pass data back and forth between themselves and through anything else connected. I'm going to go ahead and end the video here. We can just keep talking the Q&A.